let's take a look at this problem. We've got f of x is equal to 3x squared plus 1 over x squared minus 4. Okay, well, let's first find our x-intercept. To find the x-intercept, you plug 0 into the other variable, so we'll plug 0 in for y. So I got 0 is equal to 3x squared plus 1 over x squared minus 4. Whenever you're finding the intercepts and you got a single fraction equal to 0, you can just set your top equal to 0. So 0 is equal to 3x squared plus 1. Take the 1 over the left side, becomes a negative 1. Divide both sides by 3, and we get negative 1/3 is equal to x squared. Square root property says drop your squared, put a plus or minus square root on the other side. But a negative inside of a square root gives us an I. Now, since we came up with an I when we were trying to find the x-intercepts, what that means is it means there is no x-intercept. Okay, our y-intercept. We want to plug 0 into the other variable, so plug 0 in for x. So I'm going to have y is equal to 3 times 0 squared plus 1 over 0 squared minus 4. 0 squared is 0 times 3 is 0, so it drops away. And we got 1 over 0 squared drops away, so we got y is equal to negative 1/4. Now our vertical asymptotes says to factor the top, factor the bottom. Well, we got f of x is equal to 3x squared plus 1 over x plus 2 times x minus 2. Now, that was difference of two squares I used there. Now, step 2 for vertical asymptotes was to cancel. Well, there's nothing to cancel, so then I go to step 3. Step 3 says set the denominator equal to 0 and solve it. So we got x plus 2 times x minus 2 is equal to 0. We'll set each factor equal to 0, so I'll set x plus 2 equal to 0, and I'll set x minus 2 equal to 0. And we get x equals negative 2, and x is equal to positive 2. And those are our vertical asymptotes. Now our horizontal asymptotes. Degree of the top is 2, degree of the bottom is 2, so the degrees are the same. So we're going to create a fraction by taking the numbers off the front of the x to the largest power. So there's a 3 before the x squared on top, and there's an invisible 1 before the x squared on the bottom. And we get y is equal to 3. Now we want to find the increasing, decreasing, min and max, and we have to use the derivative. So the top part will be p, the bottom part will be q, and we'll use the quotient rule. P prime, the derivative of 3x squared plus 1 is 6x, and q prime, the derivative of x squared minus 4 is 2x. So this is increasing, decreasing, mins, and maxes. So for our derivative, I decided to write my formula down. There we go. Formula is p prime q minus p q prime over q squared. So our derivative, p prime is 6x times q, which is x squared minus 4, minus p, which is 3x squared plus 1, times q prime, which is 2x, all over q squared. Now I'm going to double check myself there because I was sitting there worrying about running out of space. Not thinking about my problem like I should. Okay, minus that. Okay, that looks good. Now I want to do a little bit of simplifying. Top part, I noticed that this group and this group have a 2x in common, so I can factor it out. Now 6 divided by 2 is 3, and that x is gone, and we got x squared minus 4. Minus, that 2 is gone, that x is gone, and we just got 3x squared plus 1 inside of parentheses left. All over x squared minus 4 squared. Which gives us 2x times, I'm going to multiply the 3 through distributive property. 3 times x squared is 3x squared. 3 times negative 4 is negative 12. Remember, if you have a negative in front of your parentheses, that's going to flip the sign of everything inside. So the 3x squared becomes a negative 3x squared, the 1 becomes a negative 1 all over x squared minus 4 squared. That gives us 2x. Combine together like terms. 3x squared minus 3x squared drops away. Negative 12 times negative 1 gives us negative 13 over x squared minus 4 squared. 2 times negative 13 is negative 26x over x squared minus 4 squared. Okay, well, we're ready to find our critical values. Whenever you got a fraction, you set your top part equal to 0. So negative 26x equals 0, and you set your bottom part equal to 0. So I got x squared minus 4 squared equals 0. Now this one, we can divide both sides by negative 26. And when we do that, 0 divided by anything is 0. Over on this side, remember whenever you have a parentheses to a power equal to 0, you can just drop the power. So we've got x squared minus 4 equals 0. Take the negative 4 to the right side, becomes a positive 4. And square root property. Drop your squared and put a plus or minus square root around the other side. But square root of 4 gives us 2. Okay, so we're going to have x is equal to negative 2. X is equal to 0. X is equal to positive 2. And then over here. Clear over here is negative infinity. Clear over here is positive infinity. I want to choose test cases, something between negative infinity and negative 2, like negative 3. I want to choose something between negative 2 and 0, like negative 1. Something between 0 and 2, like 1, and something greater than 2, like 3. Now we want to plug those into our derivative, which is right here. But it's easier than it looks. The bottom part's squared, so it's always positive. So all I need to do is plug it into the top part. And all we care about is a sign, so it doesn't matter about the value. If I plug negative 3 in for x, negative 26 times negative 3 is positive, so this is increasing. If I put negative 1 in there, negative 26 times negative 1 is positive, so this is increasing. If I put 1 up here, negative 26 times 1 is negative, so it's decreasing. And if I put 3 up here, negative 26 times 3 is negative, so it's decreasing. We have 1 max, assuming the original problem exists at 0. If I scroll up, it does exist at 0. So our max is going to be 0 comma something. Now we want to plug that back into our original function, and I probably don't need to use a table for this on the calculator. If I put 0 in for x in my original function, I got 3 times 0 squared plus 1 and 0 squared minus 4. Well, these x squareds would drop away and we'd have 1 over negative 4, or negative 1/4. So our max is 0, negative 1/4. Okay, let's see what we got. Scroll up. No x-intercept, but y-intercept is negative 1/4. Okay, so I got 1, 2, 3. Negative 1/4 would be, I don't know, about right there, maybe. Okay, vertical asymptotes at negative 2 and 2. So I'll come down here to negative 2 and put my vertical asymptote. And I'll come to positive 2 and put my vertical asymptote. Now horizontal asymptote is y is equal to 3. Okay, so 1, 2, 3. Okay, now going up to negative 2, this tells us it's increasing. And if I put it down here, it'd be decreasing, plus we'd have to have an x-intercept, which means it has to be up here. So it's increasing. From negative 2 to 0, it's increasing. Well, can't put it here, it'd be decreasing. And if I put it here, it looks like it's going to come through here. And it can't go above the x-axis because there's no x-intercept. So that means it must come back down. And you can see, it's increasing, reaches that point, and then decreases. And 0, negative 1/4 is our max. So it's going to look like this. And over here, 2 and beyond, it's decreasing. If I put it here, it'd be increasing, but even more than that, it'd be an X-intercept. So it has to be up here. So that'd be decreasing. And that's our sketch.